Hi everybody, welcome back. I'm going to show you now the second way in which you can find the percent composition. And if you read this question over, you'll notice that there are no masses given at all in this question, okay? Now, in a question like this where no mass is given, I could just give you the formula, or I could give you the name. In a case where I know the name isn't going to help you to get the formula, then I would give you both, okay? But I could give you something like sodium chloride, and I'm assuming that you know the formula is NaCl. So nomenclature does come into play a little bit on something like this. Now, what we're going to do is we are going to use molar masses to do this. So you need a periodic table handy. And again, one of these things, you pause the video as you see necessary to run through this as well, okay? So the first thing we're going to do is we're going to write down all of our givens. So we know by looking on a periodic table, the molar mass of carbon is 12.0 grams per mole. Molar mass of hydrogen, 1.0 grams per mole. We know the molar mass of oxygen is 16 grams per mole. We get those just by looking on the periodic table. And we also have to figure out the molar mass of cinnamon aldehyde. All right. Now, we know that this compound consists of 9 carbon, 8 hydrogen, and 1 oxygen. So I've already looked up the molar masses up here. So I'm just going to plug them in. And as I'm doing this, this is another example why molar mass is so critical. Because if you get the molar masses wrong on this, then obviously you're going to get this question wrong. So when you do the calculation, you're going to get 132.0 grams per mole for the molar mass of the compound. Now, if I want to know the molar mass, the percent composition for carbon, I'm going to take the molar mass of carbon and I have to divide it by the molar mass of the compound, and then I have to multiply this by 100. Now, this is the biggest mistake people make on a question like this. You have to remember I have to multiply it by 9. I have to do that because there's not 1 carbon, there's 9 carbons. I want to know the molar mass of all 9 carbons in this compound. So when I do this calculation, I'm going to end up with 81.82%. Okay? If I want to know the percent of hydrogen, I'm going to take the molar mass of hydrogen divided by the molar mass of the compound, multiply it by 100. And again, I have to remember, I have to multiply this by 8 because there are 8 hydrogens per molecule. So when I do this calculation, I end up with 6.06%. And then when I want to know the percent of oxygen that's going to be in this compound, I'm going to take the molar mass of oxygen divided by 132, multiply it by 100%. And I know mathematically people are going to be like, well, why are you even bothering multiplying by 1? The reason why I'm doing that is it just gets me in good habits to not forget that I'm doing that. Particularly if I'm looking at this example in studying for a test and studying for the exam, or even doing the homework questions that you're going to have to do. So when I do this and I multiply them together, I get 12.12%. So again, all of these percentages should add up to 100. If you have time at the end of the test or the end of the exam, that's something that I would do just to make sure that you haven't made a silly math mistake or a silly rounding mistake. Okay? So hopefully you're able to handle all of the questions on the worksheet that you're going to be doing. Good luck.